Let's talk about Git in more general. Oh, I didn't update the number. That should say 7. I moved this lecture from next Monday to this Monday, so just ignore that number there. This is happening today, right now. Why is Git bad? So let's talk about Git and more generally version control. Git's not bad. Git is a great tool, but it can, just version control in general. It can be tricky. So let's talk about why we're learning this first. The one constant that we'll talk about throughout this, the reason why we're using Scrum and the reason we like agile development teams and developing with agility, is because everything's going to change. Everything changes. We never know what we're going to build. We never know what we're going to break. And this applies to the customer relationship, as we saw with Scrum and Agile, but it also applies within a development team. You never know how you're going to implement a method. You never know what's going to break and what kind of crazy code you're going to come up with that just doesn't work or doesn't play well with others, or works and just doesn't integrate with the rest of the project. Lots of things can happen. So this is the one thing that we're going to always have to deal with. Yeah, Git does save lives. I didn't mean to be harsh on Git, but once you get a merge conflict, that's when Git destroys lives. How do we acquire the Apache server to host your website? Send me a message on Slack if you haven't already. I have a few unreads that I have to get to, so if you already did, I'll get to you. But yeah, send me a message. I'll get to you. Any lecture activity today? It drives me nuts when questions like that. No, there's no activity today, but I always have to question why you're asking. Like, just go to lecture, and if an activity happens, go, oh, I guess we're doing an activity. If you're asking that, in my mind, I always think, oh, this student just wants to cut out right now and not watch lecture. Which is why activities exist, by the way, because without any activities, y'all just don't do what you're supposed to. But I don't want to be down. I don't want to be a downer. Anyway, Git, created by Linus Torvalds, the creator of Linux, who graciously named it after himself. He's very open about that. He's like, I just named things after myself. He was the creator. Git is a version control. I should introduce what Git is, really. So Git is version control, which means it's going to it's made for sharing in tracking source code. So when you work on a project, instead of just having a directory with all of your code in it, we're going to use Git to be able to track all the changes that have been made to it, who made those changes, what branches exist, things that we'll talk about in today's lecture. So we want to be able to control our code somehow and remember it. So Linus created this for the Linux kernel, and a lot of the kernel developers started using it. Now they all have to use it because that's how the Linux kernel is controlled. And but that was the start of Git. All the solutions out there at the time, there are other types of version control. Linus just wasn't happy with. There were issues, with them, regardless of what the issues were. He had issues with each one of them. So he created Git in, I want to say, a couple of days. He did it really quick. He said, I can create something better than all of these other solutions. And then he just did it in like a couple days. And now pretty much the whole software industry is using this thing. It's really incredible what he just created, because he needed a better solution to work on the kernel. And he just created a better solution. Really phenomenal. So with the kernel, since that's the origins of Git, is the kernel, it is designed for the specific issues with that. The kernel is a very large code base, and it changes often. So speed is emphasized, and also space. The amount of storage used by Git is quite minimized. Only the changes, every time you change the code, only the changes are recorded, not the entire state of the code. It's really optimized for a large dynamic code base, which is what the Linux kernel is. It's always changing. The name doesn't mean anything. Linus does like to name things after himself, but this isn't one of them. He just came up with Git somehow. So it's not an acronym, doesn't stand for anything. It's just Git. So, and with this, we have a shared repo. Actually, this I want to talk about on the next slide once we have a picture. So we have one shared repo, the central repo. For our cases in this course, it's going to be the repo, the state of the repo on GitHub. So this is GitHub for our purposes. And then every team member is going to have their own copy of the repository on their own machines, where this is the internet right here. And you have on your machine, on your laptop, your desktop, whatever, your phone maybe, you have your copy of the repository that you can work with and update the GitHub repository. So we have one central repository. This is what everybody agrees on is the repository. This is the one your project manager is going to have access to, the one on GitHub. So everybody's working on that central repository. Each member has their personal copy of that entire repository. So all of the code, including all of the history, all the changes that have been made to that code, your copy of the repository is the entire repository on GitHub. So you're all working on your own code. If GitHub, all the servers were destroyed overnight, maybe they have massive hard drive failures across the board and your repository no longer exists on GitHub, it doesn't matter all that much because you have an entire copy of the repository. As soon as GitHub gets some blank hard drives loaded in there, you just push your whole repository on there and you didn't lose a thing. You would lose technically, you would lose like your GitHub issues and things that aren't part of the repository. Your GitHub wiki, for example, is actually a separate repository. Let's not get into details. You don't lose your code if GitHub goes down. You still have your code, the entire repository, all the changes, all the history, all the branches, everything. Copy of the repository. And then where you actually do your work is going to be your working copy, where this is where you actually have your editors open and you're actually changing the code and modifying copies of stuff as you work. When you work, you are not modifying the repository itself. So when you're typing code, you're actually typing your code in the editor. You're not editing the repository directly. When you're happy with your files, you edit your file. So if this user has their working copy, you're changing your code, you're writing classes, you're writing methods, you're happy, you're plugging along, edit some files, and you're happy with how it is, and you want to get this code in the repository, you do this in two separate steps. First, you're going to commit your local changes of your working copy into your local version of the repository. So your copy of the repository from the central server, you commit your changes to your local copy, and then you push those changes to the central repository, to the server. So there's two steps. Those of you who've used Git before, you're aware of this. But this is where that distinction comes from. I question this when I first learned Git. Like, why can't there just be one command? Like, get my code on the server. That's what I really want. But this does happen in two separate steps. Commit to your local copy of the repository, push to the server. If you commit without pushing, nobody on your team can see your changes. And that does happen from time to time. I've had students only commit without pushing, and then they're like, why did I get a 0 on that assignment? Well, I can't see any code. From my perspective, you haven't done anything. And within a team, if you put commit without pushing, your teammates can't see anything, so your teammates think that you haven't done anything also. So it's very important to do both commit and push. If you're using an IDE, usually this does become one button. There's a commit and push button somewhere, and you can kind of pretend that that's all one motion. If you're using the command line, these are separate. You actually have to add commit and push if you're using command line, which I don't recommend unless you really know what Git's all about and you want to learn the nuts and bolts of it. Yeah, you can't commit if you don't add your changes first. If you use an IDE, it'll take care of a lot of this for you, which I always recommend. If you really want to get down to it and do some command line editing, you have to add your files, then commit them, then push them. So there's 3 steps to the process in that case. Yeah, if you want to use Emacs, so here's my stance on that. If you want to use something like Emacs or Vim or whatever, or even like Atom, any or Notepad++. If you want to use a text editor and not a full IDE, be my guest. Please do. Just if it causes issues, don't ask me about them. Don't ask me to help solve them, because there are solutions. It's called IDEs. There are answers to your questions. It's called using the tools available to us. Yeah, Ethan. Yeah, Ethan doesn't like when I say this, but I'll still say it. Like, there are solutions to these problems. If you know how to use those tools, like in Ethan's case, if you know how to use those tools, because they can be more effective, you can be a more effective developer with those tools than without, then by all means go ahead. But if you're struggling at all, those tools are hard to use. If you're struggling at all, don't bother. Don't do that to yourself. The worst is when I have 116 students complain to me, like, I don't know how to do this thing, and they pull up Vim. Like, if you don't even know what's going on, why are you using Vim? Like, I told you to use IntelliJ for a reason. Anyway, let's not bother. Yeah, use those tools if you know how to use them. If you don't know how to use them, stay away from them for now, unless you're willing to learn new things, which you always should be. But anyway, if you have time to learn more new things on top of your course load. Anyway, that's I'm getting too sidetracked there. So once you push your changes to the central repository, now your teammates can pull those changes from the repository. So there's a bit of vocab here that you need to know with Git if you haven't used it before, which I believe you've all taken 116 at the time where it used Git. So I do assume a good amount of background in Git. But I want to go over some things that, in some detail that we probably didn't do in 116. When with the time frame, most of you probably took 116 with Dr. Hertz. Some of you probably took it with me. But either way, we didn't go through too much detail. So I won't go through more detail. But you probably heard these terms, I do assume. So from the central repository, your teammates can pull those changes. That updates their local version of the repository to be in sync with the central repository on GitHub. And then they can update their code to their working copy. Again, in IDE, this is one button. You pull and update your editing. So I think that is command line too. So you pull the changes, and now they can see the changes that you've made to the repository. So you're all working on the same code base, but you have your own copies of it, and you can share them through pushing and pulling using Git. Yeah, pull before push. I'll remind you of that in a few slides here too. And it's always helpful to be on the latest edit. So if your teammates push some code to the repository, pull that code. I think it's the next slide. Right? It's going to be the one after that, I know. But everyone can edit the code separately. Everybody has different versions of it. And when your teammate's pushing to the repository, it's always helpful to get those copies, to get those changes, to pull those changes into your code to make sure that your code is going to be compatible with your teammate's code. It's possible that you're both modifying the same file. If you're both changing the same file, you need to know that those changes are going to be compatible, that they're both going to work. And I recommend agreeing with your team that once you divvy up the tasks in a meeting, deciding which files each person is going to work on to make sure you avoid those kinds of issues, because it can get messy, and we will talk about those a bit today. I want to mention that early, though. And everybody can work at the same time, so everybody can push at the same time, but whoever pushes first, nobody else can push until they pull. You always, and this is what we're talking about in chat, you have to pull before you push. So you can't push conflicting changes to the central repository. These two teammates are going to have to pull those changes that this third teammate made. You have to pull those changes and integrate those changes into your local repository before you can push. Now, if there's no issues here, that just means you have to pull and then push. But if you have some conflicts, you might have a scenario where you have to pull and have a situation where you both edited the same file in a way that Git can't figure out which code goes where, whose code should stay, whose code should go, how to merge these things. So we're going to have a conflict here. and you can't do anything with this repository. You can't push, rather, until you resolve the conflict to merge your changes with the changes from your teammate into that repository. And once you resolve those conflicts, then you can finally push to the repository once the code is in a state that is not in conflict anymore. And this is what we call a merge conflict. So when you have incompatible changes, you'll have a merge conflict, and these can be tough to resolve. The Git will try to merge. It has an automated merger, but if you edit the same line on the same file, and sometimes even when it's not the same exact line, but there are so many changes that Git just can't merge them together, it's going to ask you to manually resolve these changes. It's going to ask you, hey, I had an issue here. It's going to mark up your files a bit and say, what do you want me to do here? How do I resolve this issue? You're going to have to manually fix that, manually merge the code, and then finally you can push that code, that merged code. This can be painful. This is what I mean when I say Git can destroy lives. It's when you have merge conflicts is where things become problematic. So if you're both editing the same file and you're not really agreeing on who's changing what, and you both just completely change that file, especially when you're first starting out, the file might have the equivalent of like hello world when you both start, and then you both write the file, write different functionality but in the same file, and then try to merge them together. You might have some big issues. Maybe you're writing a class and you both you didn't agree on the constructor parameters, and you have two different parameter lists for the constructor of this class. Well, now what do you do? Maybe you're in a language where you can overload the constructor, and that's fine. If you're not, what do? You got to figure something out, and it's going to be a lot of manual work. And this is where team members can get in conflict. This might be where you have to enact your conflict resolution strategies as well, which hopefully everything goes smoothly with all your teams. But you can get in situations, and this can happen, where there's a merge conflict, and whoever pushed first claims that it's not their problem to resolve. So if you have a merge conflict, either it's a harmless one and somebody's just got to do the merging of code, or you didn't communicate enough and agree on the interfaces of how these separate modules are going to interact with each other, and then that caused a merge conflict. If you get in a situation where there was a miscommunication and whoever pushes first claims it's not their fault because the second push is the one that caused the conflict, that's where you can have some personal conflicts within your team. It's always messy. It's tough if somebody acts like that. So that's what we really want to avoid. More communication about exactly what each person is writing. What are the APIs? What are the how is each method going to be called? What are all the parameter lists? What's each class going to name its methods and its variables? What's going on with that? Agreeing on that beforehand can really limit these conflicts, or coding up completely separate modules. You work on front end, I'll work on the database, and then have somebody specifically their specific role is to glue this code together. That can work also. But whatever you do, think about this now. Think about this beforehand, so you don't have huge merge conflicts. Because usually it's one person on the team, or at least the issues that come to my attention, it's one person on the team stuck merging everything, usually right before the deadline. Because everybody's like, well, I finished my thing 1 hour before deadline and I pushed it, so not my fault. I finished my stuff. If it's not compatible with the rest of the project, you might as well not even written it, because you're just going to cause more problems than you fixed. So one way to avoid conflicts: pull frequently, pull often, pull all the time. Always have the latest version of your teammate's code whenever you're working. Is one step that can limit the issues. That has its own issues, but what if your teammates aren't pushing frequently is an issue. That they're just not sharing their latest code, and then they push all at once. That's a problem too. So I don't want to just read this slide to you. I'm going to talk about it in a scenario. So let's talk about another scenario. Susan, that we talked about earlier in the semester. Say Susan's working on the back end of a system. She has a lot of work to do. It's going to be great once it's done, but it's going to take weeks to finish. So she's going to often push unstable or broken code during those 2 weeks because she wants her changes in the repo. She's pushing often so people can pull often and get the latest code. Meanwhile, John is messing with the front end, just making cosmetic changes, and he's continuously pulling because that's what he learned to do. And he's seeing errors as he's making these cosmetic changes. Things are breaking, and he's naturally attributing it to his code that he wrote, thinking that he broke the code. When actually it was just that Susan pushed code that wasn't quite finished yet. So he's seeing the side effects of her code. So nobody's really at fault here, but John is going to be driving himself nuts trying to debug this code when the changes are on the back end and not the front end in code that he might not even know about. So this is tough. This is John. He's going nuts. And what do we do in this situation? How do we prevent something like this? So this is, so you should be pushing your code and sharing that code often, but this is a tough thing. So one solution, a terrible solution, is to just not push until you have complete code. So Susan working on her code that's going to take weeks. Just wait weeks, only committing locally and never pushing to the server. So this is one solution, awful solution, and here's why. Hard drives fail. This is a part of our lives in computer science, in computers in general. Hard drives fail. They don't fail too often, just your personal machines. You might not have experienced too many hard drive failures, maybe even experienced zero. But they do fail, and if you have a server with lots of hard drives, these rates add up. You get quite a bit of hard drive failures every year if you have a lot of them. But you are risking this chance that your hard drive is going to fail before you push. If you have 2 weeks of work sitting on your hard drive locally, only committed to your local copy of the repository, and your drive fails, you lost all that work. If you push it to the server, at least the server has it, and anybody who pulls has that code. You have copies of that code all over the place. Locally, you're one hard drive failure away from losing weeks of work, and that is not a fun spot to be in. That's very stressful, knowing that one thing can happen. Or maybe you just drop your laptop and break your hard drive. It can happen. So even if your hard drive doesn't fail, there's still this issue. Everybody's working on their separate code, and everybody waits to the week of a deadline, and everybody pushes, and there are merge conflicts aplenty. If this is what your team's doing, everybody's waiting to the week of the deadline to push, you're going to have merge conflicts. Unless you really communicated well and agreed on who's working on what, you're going to have some merge conflicts there. And it's going to be tough to resolve. And these are the situations where, let me get to the next slide. Even worse, everybody waits to the day of the deadline. I'd say this is more common in 442 at least. More common in this class. Everybody waits to the day of the deadline. Usually all working up until, I suppose the meetings are the technical deadline now. So like the morning of the meeting or the night before, everybody finishes their code, rushes it, and then pushes it all on the day of the deadline. Who resolves those conflicts? And these are the issues that usually I have a team sitting in my office saying, what happened? And one person on that team was kind of left with shambles of a project trying to resolve all of the conflicts, because it's common for somebody under the stress of trying to rush a sprint's worth of work right at the end, or maybe they just didn't push until the end. They push, it says, the repo says you got to pull first, there are changes. They pull, hey, you got merge conflicts, and they just click, I don't know, auto resolve it, or just starts deleting stuff and just really haphazardly merges the code and breaks everything. It happens. It sucks. You're gonna be mad at that teammate. It's inevitable. That you will be mad at them if they do this. It will be inevitable. Not inevitable that it'll happen. Hopefully you listen to this lesson and nobody does this. But then it's usually one person left with the project trying to merge everything. And it's usually whoever cares the most about their grade. And everybody else is just like, I'm fine with a C, whatever. These things happen in their nightmare situations. It's really, really awful. So hopefully this doesn't happen to you. If your teammates go a while without pushing, nudge them a little, be like, hey, can you get your pushes in that repo, because, we need your code. Yeah, and don't do git merge force. Please don't do that. I think there's a slide. I might have deleted that slide, but there was a slide if there isn't still. Git merge force just overwrites everybody else's changes and says, my changes are the changes that will exist in our project, and just deletes everybody else's if there's a conflict. Don't do that. I shouldn't even have to say it, but don't do that. Just don't. Unless maybe there's always exceptions. Maybe if you're the one who's stuck merging everything, and you just say, that code was crappy anyway, But anyway, so a good option is to fix these merges as you're going through the project. Always push, always pull, and make sure everything's compatible. If something's not compatible, contact your teammates. But when you do have to fix the errors, you got to go line by line and decide which code stays, which code goes. Because Git isn't always going to be able to determine which sets of lines of code are actually going to create a working program under your vision and complete your user stories and everything. Git's not that powerful. You're going to have to go line by line and fix these issues. There is one option. I'm actually in the process of doing this myself right now. I had some half-baked features, and I did exactly what you're not supposed to do. And this is in a side project with someone else. And I wasn't always pushing my changes, and me and my teammate weren't always on the same page, the same changes. We were working on separate branches, which we'll talk about in a second. And our code just wasn't compatible at all. We both made fundamental changes on the project. And I'm at this spot. I deleted the project, cloned it, and I have my local changes for my changes, and I'm just manually going through and adding my changes to his version of the code base from his branch. It's painful. It sucks. I can't wait for this process to be done so I can be back on track. But you don't want to ever be in this situation. I didn't actually delete the project. I just switched to his branch, and I branched off of his branch, and then I'm adding my changes into that new branch. And then I'm going to merge them back in. It's not a fun situation to be in. You don't want to be in a spot like this. I can tell you, because I'm living the pain right now. But it obviously does happen when you're not careful. If you're not careful, this will creep up on you, as it did me. It's not ideal. Sometimes that's what you're doing. Once the issues, so I did resolve all the issues. I went through all the conflicts and resolved them all, but the code was just so broken after I resolved them, because I don't know, I didn't quite rush it, but we just both went in different directions in our separate branches. And I couldn't keep my changes and do his. Hey, I did use this. So, or you can be a jerk and just do git push force. I could have done this and made my teammate fix all the issues. Don't do this. Just don't do it. If you do, your teammates are going to be looking for a new team member. They're probably going to talk to me and be like, we cannot work with this person anymore. They did a push force. And I'll be like, I understand. And I don't know. I'll do what needs to be done at that point. But don't do that. So finally, let's talk about branching. Branching. So to avoid some of those problems, we're going to use branching, specifically the one with, I forgot the names of the characters in that scenario. But when somebody's working on the back end, making weeks-long changes and pushing to the repo, Well, somebody's working on the front end, John and Susan. So Susan was working on the back end, John was working on the front end, and their changes were Susan's changes or half completed code was affecting John's front end. We had this issue. So branches are going to solve this problem. I shouldn't say solve so strongly, but branches are used to address this issue. So this allows developers to work completely independently, so they can still push to the repo, so they're not vulnerable to a hard drive error, and they can still share their changes with the rest of the team, but they're not going to break each other's code. So we solve all the issues. No hard drive issue. I shouldn't say all again. No hard drive failure issues. Other teammates can still merge your code into theirs to make sure everything's compatible, but they don't have to, and because they can work independently with their own versions, their own copies of the code base. So this is what we'll do in this class. There are lines, at least one on your rubric, to make sure you're using proper branches. If you're not, I think you should just not get any points, but Hertz. I read Hertz is off in the spring. I'm like, oh my goodness, who's teaching his classes? I don't want to teach double the courses. Offspring. His own children. Yeah, I see. Because that's Matt's kids, it must be. I probably should know the name of his kids. I guess I don't. I do now. So branches are going to help this, and we're going to talk about branches on the next slide. So with branches, you're still going to get conflicts. You're still going to have merge conflicts. It doesn't solve that part of that aspect of it. It can if you're using branches wisely, but you can, obviously in my story, we're using branches and we still have conflicts. You can still get conflicts if you're waiting to the last second to merge those branches. So one thing that I should have done in my example, my story, my misery I'm living through right now, is constantly merging my teammates' branch. All the changes, all the commits and pushes that they made to their branch, I should have been merging into my branch to make sure that they were compatible throughout. We went, weeks, maybe a month without doing that, or I did anyway. And that's where the issue came in. So it's not going to just get rid of all your merge conflicts if you're sloppy about it, like I was, but it can get rid of your merge conflicts if you're still merging in that code whenever you're ready. Like, write your code, commit, push, test, make sure it's working, and then merge. And if things break, you know exactly what code broke it. It was your teammate's code, and then you can go in there and make sure that your code is compatible with each other as you're working on the project. So let's talk about branches. So branches, the one-liner is each branch is a complete copy of the repository. And Git is smart about how it does this. It doesn't actually copy the entire repository, but the details are less important for our purposes. But it's effectively a copy of the entire repository, the entire code base, that can change independently. So we start with these two branches. Every Git repository you create is going to have a master branch. So all your projects all have a master branch. Right now, when you create the Git repository, you get a master branch. You should never touch this branch except through a merge from develop. That's the only way you ever touch master. Master's never directly touched. Nothing changes really on master unless it's from develop. And we'll talk about that in this lecture. This is only code that has been released to the customers and to the clients. This is the current state of your app that is customer and client and user facing. So this is only release code. Every time you merge into master, every time the master code updates, you're changing your version number. So with software you use, software goes from version 10.1.3 to 10.1.4. That means they merged into master, updated the version of their code on master, assuming they're following this branching model. They updated their code on master. They moved to a new version of their software, and this is where we really get the term version control. Master is going to control the actual released versions of your software and mark each one. So if you want to go back to an older version of your code, you'll go back a few commits in master, and you can go see that exact state of that older version of code, and Git will let you go through the history of your code like that. Develop is the latest set of completed features. If you're using some software, I believe browsers do this. I believe Chrome. I know Firefox does. You can actually download the develop branch version of the software, which is going to be all the latest features, which might not be fully tested. I mean, they're tested to a degree, but they're not. They haven't withstood the test of time yet. They haven't been released to the public and made sure they're really stable. But they will have all the latest features that are developed at that time. This is where you're going to add all your features. You're going to complete a feature. You're going to merge it into develop. And then that feature exists on the develop branch, the develop version of the code for that. This is where, this is the branch you're going to start with too, whenever you start a new feature. And I want to talk about that more when we get to the pictures. And yeah, never push incomplete code into develop. Never push to develop at all, but never merge incomplete code into develop. Hey. Oh, yeah, master. I would expand this to never commit directly to develop as well. I don't know how strict we are. I'd have to double check the exact wording of the rubric on committing directly to develop. But if I ever see it, it's going to weigh my my grading decisions. I don't think you should never be committing or pushing directly into master or develop. So how do we act? Well, let me say that in a little bit. So from master, we're going to create the first thing you should do in terms of branching, and I recommend you do this right away. You're starting sprint 1. So you have to start working. So what you should do, at least by the end of today, is create that develop branch. At least one of your teammates, only one person has to do this. But create the develop branch off of master, so you can start working in master. Each one of these circles, by the way, is a commit, or a commit and push, where you're updating the repo with your new latest code. So you start with master. It just has no code in it. It says initial production version, but when you first start, it's going to have nothing. Create a branch off of master, and to do this in GitHub, go to branches, and there will be a text box there. Make sure you're on whatever branch you want to branch from, and then type in the name of the branch you want to create. It's going to create that branch, which is a complete copy of the branch that you are on. So if you're on master, which is the only choice when you first start, and you type in develop, it's going to create a develop branch, which is an exact copy of the code on master, except now each can be changed independently. So as you change code on develop, master doesn't change. And then once you're happy with develop, you can merge all the changes from develop back into master once you're ready for that first release, which would be the end of sprint 1. So you should ideally only have master changing 4 times throughout the whole semester, just for the 4 sprint deadlines. So the only 4 times we're actually technically releasing code to the customers and updating the version of your software. Everything else is on develop. But I said we don't push to develop directly. So how do we actually change either one of these branches if we're not pushing or committing to master or develop directly? How do we actually write our code? What do we do when we do git commit and git push? What do we actually do? So for that, we're going to branch off of develop. So we're going to create a branch starting with develop. We're always going to start our new features from the develop branch. So we want a complete copy of whatever's on develop, all of the latest features, create our branch, and that's where we're going to start writing our code. And we're going to create our, what we call feature branches for each, at least one for each user story off of develop. We're going to create a branch for that story and then work on our code there. So a story, so we're going to create our feature branches off of develop. That's where we write our code, and this is where we're actually pushing committing and pushing our code is to these branches. And I saw the question in chat a bit ago, should every developer have a separate branch? I recommend every developer have a branch for each feature that they're working on. I would say even further than every developer has a branch. Every developer should have multiple branches. The project I was talking about, there's 2 of us, and we have like 5 branches each that we're working on, just different features that we're working on. Granted, we don't need that many, but if I'm working on one feature and I want to jump over to another one just to get a feel for it, but I'm not quite done with the first one, I'll create another branch so I'm not mixing all my changes, and I might have the project in a broken state on one branch. And I want to start from develop on another one and play around with another feature. It's a project we're just doing for fun, so we like to do stuff like that. But yeah, every task should have its good one pockets. Every task should have its own branch. So you take a story, create a branch off of develop for it. This is what I would recommend. Create a branch off of develop for each story, and then off of that story branch, create a branch for every task for that story. So you're going to break a story into tasks. I would have the branching model reflect that exact change. Stories branch off develop, and then features branch off of the story for each task that you need to complete. And then each time a task is complete, merge it into the story branch. And then once all those tasks are complete, merge the story, do the acceptance testing, then merge that story into develop. That would be my recommended workflow. I don't think it says it on the rubric, but make sure you check with your project managers. If you want to and they say that it's fine to do this, you can have your task branches directly off of develop. Actually, no, that would be problematic. You can't do that. Never mind. Story off of develop, and then tasks off of story. So you can have all the code organized for that. So yeah, and be liberal with your branches. Everybody gets a branch. Everybody gets multiple branches. However many branches you want. If you got 1,000 you shouldn't have 1,000 branches. But if you have 20 branches in your project, go for it. Do however many branches you want. You should have at least nine branches, master, develop, and 7 stories. You don't have to do all 7 of those stories for sprint 1, though. Don't create the branches until you're ready to write the code. So you shouldn't have 9 branches right now. But once you have that story, once your team chooses which stories you're working on for sprint 1, create those story branches, and then you can create further branches off of those for each task, is what I would recommend. But not until you're ready to work on those. You choose a story, create that branch, somebody creates that branch, you're ready to work on a task related to that story, create another branch off of that story branch. Dev story task pain. Yeah. How many stories should you do each sprint? It depends on the size of the stories. Talk to your project manager about it. But if you have one massive story, well, first I would recommend breaking up massive stories into smaller stories. But if you have a massive story, maybe 1. If you have a lot of small stories, I don't know, 5. But there's no solid number on that. Talk to your project manager and your team and decide what's good for a sprint. Always branch off develop. Let's make that clear. So, and it's okay. And part of what I mean by being liberal with the branches is if you have an idea for a feature, just make a branch and start coding. Just start doing whatever. It's okay to delete branches without ever merging them into develop. So we can, if we have an idea and it doesn't work out for us, just delete that branch. No harm done. Who cares? You lost some time, so maybe you care, but you haven't tanked the project. You didn't drive the project into the ground with your failed idea. So this is where branches really come in, and that's why we have so many branches in that project I mentioned. Sometimes I'll just be like, I have this crazy idea, and I just want to hack away and flail around with some code. And sometimes it doesn't work, and then I just delete that branch. Like nothing ever happened. If it works and I like it, then I'm going to talk about merging that into develop, and maybe we'll take that feature. But you only merge into develop that story branch. You only merge it into develop after, and I mentioned this earlier, but after the acceptance tests pass. Make sure that story is complete. Make sure the acceptance test pass. If the acceptance tests don't pass, you have no business merging that into develop, because that feature does not exist yet. You're effectively merging broken code into develop. Acceptance test pass. Talk to the team. Hey, this is done, I think. They can verify. You can talk about it in the meetings, and then merge it into develop once it's verified that it works. Never ever commit to master. Never commit to develop either. Notice how we're doing this through merging. We create the story, complete the story in the story branch, and then merge it into develop. Nobody's committing into develop or master ever. Ever, ever, ever. Develop should be as stable as reasonably possible. Master should always be stable. Develop might be unstable if two features, tested features, are great, but they're just not compatible with each other. You can still have integration issues like that. But develop is as stable as reasonably possible. If you're pushing directly to develop, you're probably going to break develop. So that looks like this, where feature branch would be our story branches, and then we can branch off of those also. Or you can try anybody who's working on a single story, all those tasks, try push into the same branch. You might have the merge conflicts there, so I don't really recommend that. I would create a branch for each developer off of these story branches. And creating story branches, by the way, that helps your project manager see the state of each story. They can see, it's easy for them to see exactly what the state of the code is and how much you've been working, how far you are along on that feature. No fast forward. So when you merge so like in this picture, it's on the screen. So in this picture, after you merge this feature branch into develop, and by the way, after you merge a feature branch into develop, you can delete that feature branch. You don't need that branch anymore because that story is complete. You don't need it anymore. If there's a bug, you need to change it, create a new branch to fix it, and then merge it back in and delete that branch. So after this branch is merged in and deleted, there's a question of what to do with those commits. So if we merge, just a plain old merge, all the commits get mixed in together, and the commits that were made to that branch appear as though they were made on develop itself. Even though you didn't commit and push directly to develop, it'll look like that after you merge the changes. And this is fine. This is what I prefer, actually, is doing this. What you can do with no fast forward is actually preserve the memory of that branch. So these commits are going to still remember that they were made on a separate branch. So if you want to remember which branch the commits were made to, you can mess around with no fast forwards. Or if you don't care, you're fine with all your commits being mixed together, go with the plain merge. And speaking of commits, commit messages. This is on your rubric. This is part of how you're going to be graded. If it's helpful for your team to agree on a Git commit message convention and agree on what information should be there. I'm not too picky on what the convention is, but it should make sense. It should keep things organized. And if your project manager has some specific things that they want to see, comply with whatever they say if they need a specific thing. One of the things that I'm not sure if we're enforcing on the rubric, but one thing that you absolutely should do, I think it's on the next slide, is include the task number as the very first characters of each commit message. So if you're working on task 7, your very first characters of that commit message should be #7, space, and then the description, one-line description of your commit message. And then if there's more information needed, have a blank line, and then a description. This is what I changed in this commit. This is the code, and this is why it's wonderful and everything. That way, even if you're using fast forwards, the regular commit messages, all those commits are going to have marked exactly which issue they were resolving. What were you working on when you made this commit? So then even if all the commits mixed together, you can know what each developer was working on when they made that commit. Commit messages help you see the history of the project, all the changes that have been made, why they were made, especially if you're tagging the issues. And anybody who, this is why it's part of the onboarding part of your rubric, any outsider coming onto the project knows what's up. They know what's going on, why you wrote this code, where it goes, and also your teammates, when they look at your commit messages, like, and specifically, usually the use case I find is I see some code and I'm like, the hell is this code doing here? Like, what is this? Why would anybody write this? I'll look at the commit where that code appeared and then read the commit message and see what they were working on when they wrote that exact code. So if you have good commit messages, you can track that down and say exactly. You can go to a file in GitHub, look at the history of the whole file and see when that change occurred, find the commit message and read it and know what was going on, who wrote it first of all, because sometimes I'm the culprit and I don't remember it. Like, I wrote that shitty code. Oh, man. And so who wrote it, what task they were working on when they wrote it, what that code is supposed to do, and all that other information. The more documentation you have here, you're going to thank yourself. Your teammates are going to thank you. Anybody who's onboarded on the project is going to thank you. Just helpful to have all the extra information, all the information that you can. That's what I'm talking about. Tag the task to explain why you wrote that code. What the code is only one part of the story. The commit message, the commit itself is going to tell you what code changed on that commit. But why? Why did you make this commit? Tag the task. That says so much more than most other things you can say. It's because I was working on this task, and then this is what this specific code does in hopes of completing that task. We're 2 minutes over, so let's not go through that one. But so the state of your project, you should have master branch, develop, absolutely, and then any number of feature branches. There could be 100 of these. Who cares how many feature branches there are? But the feature branches and your story branches, in our case, this is where the action happens. This is where the code is written. This is where you're actually developing your code. This is where you're creating software. Then you merge them into develop. You merge develop after a while into master. I'm not concerned with the release branches in this course, but this model recommends branching off of develop and then doing a lot of thorough testing here in the release branch before actually releasing, and then releasing to master, and also merging those bug fixes over to develop. And also, if you ever have a bug that's been released to the public, this model recommends using a hotfix branch off of master, fix the bug, and then merge it into master and develop, which is something you probably won't use in this class. I did force this one semester where me and the TAs would go into their release code, the release code of your projects, find bugs, report them using GitHub issues, and then that team had like 24 hours to at least create a hotfix branch. I'm not doing that this semester. It didn't really work the way I wanted it to anyway. So I'm not going to mess around with that. We talked about the important aspects of this, but this is Git workflow, just expanded a little bit to store the index. This is where if you're using command line, you have to worry about adding, or if you're using an IDE, and so I use JetBrains IDEs, and if I add a file to the directory using my file system, using anything except the IDE, I do have to manually add it to the index. So sometimes with an IDE, you still have to worry about adding. But add, commit, push, those are your 3 steps to update the repo, the remote repo.